My name is Moshe Zadka. My website is... Thank you. My website is corporatism.com, where you can find every way of reaching out to me known to humankind. I work for Anthropic, and I definitely do not speak for my employer. And today, I want to talk to you a little bit about iteration. So let's talk about what's going to be on the agenda. I'm going to talk about what iteration is in Python, because that's kind of nuanced and subtle. I'm going to talk about how to do that. Then we're going to talk about how not to do it. So that'll be fun. And then I'll talk about, why you should use it and where. So, okay, let's get started, because we have a lot of stuff to cover. So, I'm sure many of you have heard the word iterable. You know what, let me start with a question. How many of you have done iteration in Python? Used the for loop, comprehension, or call the list constructor? Sound like most of you. How many of you feel like you really understand how it works internally? Great. So that's what I expected. Cool. So iterable. An iterable is a protocol that has one method in it, which is iter, and it returns an iterator. Well, I should have started with an iterator, right? Well, kind of hard, because iterator is something that inherits from iterable, right? So it also has a iter method, but it also has a next method that trains stop iteration. Now, there's one extra kind of twist to that, which is obviously it does have iter method, because it inherits from iterable, but iter on an iterator returns self. So that's pretty cool, because it means it's always safe to call iter, and that's a good segue to my next spec. We never call functions in Python directly. We always call them through an operator. And in this case, through these two things. So if you want to call the method, you call iter. And if you want to call next, you call next. That also works correctly with C types and things that don't technically have the method. So basically, that's how iteration works from the inside in Python. So let's write something iterable, right? We know what we need to do. All we need to do is put a iter method on it and return an iterator. Well, luckily, we have something that returns iterators really efficiently, right? So we snuff iter from Python, and that's an iterable thing, right? I've implemented an iterable class. Great. Now let's implement an iterator. Oh, sorry, before we implement an iterator, here's how we use it, right? So we call iter on it, right? That calls the iter method, that is an iterator, and then we just call next on it, and we get 1 and 10, right? So that works, right? That's the basics of iteration. That is the iter method. Okay, so now let's think that we want to write an iterator, right? I'm kind of cheating, and I'm not implementing the iter method because it won't fit on the slide. But I am putting two things, and whenever I call next, I just grab the next thing and pop it out of the list. But you notice that if you remember, when I talked about the protocols, when this ends, it has to raise a stop iteration error. This will stop an index error, so I have to translate the exception, and now it's a proper iterator. Well, how do I know that? Because I did this, right? So I built the iterator. You notice that I didn't have to call iter, because it's already an iterator. I called next. It gave me the numbers. But, what happens when I call next again? Well, it raises stop iteration. That's great, right? So that means we've implemented the iterators properly. And you will notice that implementing an iterator was kind of annoying and weird, and I had to do weird stuff for that, and we'll get back to that in a few minutes. But first, I called next and iter manually here, and you probably have never done that, or maybe done it half a dozen times in your life. Probably most of the time, you're gonna call for. So okay, for for, I basically also need to implement iter, and I'm also gonna add a lot of prints. Why am I adding the prints? Because I want you to see how for works. So you see I have a print from before, a print and after the for. And notice that for already swallowed the stop iteration exception that we raised, right? So we raised an exception. There is no try catch here. That exception got swallowed. That exception is what signals for to be done. So it's a very critical exception to remember, and remember to kind of raise the right exception. But then you see that, every time it calls next internally, right? You know that because it prints out from the next, and then it actually gets a value and prints out from the for. So this is a good way to kind of get visibility into like actually how for works from the inside. So if you remember in the poll in the beginning, I mentioned that like, if you've iterated in Python, you might have used one of three ways, which is to use for loops, list comprehensions, and remember the third thing, use the list constructor. So the list construction is an iterator, right? It will iterate over your stuff and puts it into a list, right? You can see that, right? It like does all the iteration before. It swallows the stop. Like, look, I do not have an explicit try except here. But if you remember, I do raise an exception. So it called all of these things. It swallowed the exception. It gave me the list, right? So that's another way to iterate. And that's important because you often don't think of it as iterating, right? And this calls arbitrary code. Arbitrary, right? I did prints, right? I could have like, connected to the internet, for the same price, right? So it's really important to remember that the list thing can call like arbitrary code. Okay, so I'm sure that if you've heard of like iterators, someone like threw away the word generator. So what's the connection between an iterator and a generator? And that's very nuanced. An iterator is a protocol. It says what you're supposed to do. Right? You're supposed to have done the iter, you're supposed to have done the next, they're supposed to like, obey certain constraints. But you remember that I wrote an iterator myself, right? And it barely fit on a slide. It was like the simplest iterator you can imagine. And it was annoying to write, right? I had to like, put state, and I had to like, put a pop and remember where I am. And that's kind of annoying. If you ever want to write an iterator yourself, you probably want an easier way to do it. Luckily, so Python has generators. Generators are a facility, a language construct that will let you implement iterators much more easily. So, why is it so easy to implement iterators with generators? So, basically this is very equivalent to like the previous one, right? It, returns the same things, 1 and 10. And it also does a bunch of prints for more or less the same reason that we did prints before, but so that you can see the prints when they come out. So, well, we all remember how to iterate through that, right? Because I did a few slides ago. So let's iterate, right? Like same thing. I write before and after. And you'll see like, it's the same flow, right? And when it gets to the end, again, remember, for only stops when it sees a stop iteration exception, which means there's a hidden throw or like a raise at the end that raised the stop iteration, and then for swallowed it and returned. So in this case, both the raise and the try and except are invisible for different reasons. The generator has a hidden raise, and the for loop has a hidden try except, so you don't see any of them. But it's important to remember that earlier on, before I used any of these like nice language constructs, they had try and accept and raise, and that was explicit. This is the same thing, but they're invisible. Okay, so yield from is really, really nice in generators because it is the equivalent of calling a function from another function, right? Except, nuance, yield from, the input to that does not have to be a generator. In fact, it does not have to be an iterator. It only needs to be an iterable, right? That's important. Remember, iterable is something that you can call iter on it to get an iterator. Every iterator is an iterable because if you call iter on an iterator, you get itself. Every generator is an iterator because we saw that earlier. So often, right, especially if you have like a recursive generator, then it will call itself. And if you have a recursion, usually that's the form it will take, a yield from. But the yield from can do anything, right? You can yield from 1, 2, and that will be fine, right? Because it's a tuple and tuple, blah, blah, blah. So it's kind of weird, but you can do that. Anyway, so you can see I do a list of that, right? It prints begin, middle, end. Those come from the yield from. I probably should have added another print before the 100, but you see, the result is 1, 10, 100. Right, so this is pretty cool. So now we get like a sense of like why generators are so useful. Because again, imagine implementing this logic yourself in a class with like a dunder iter or a dunder next method. It would be a lot of code, lots of annoying code you have to remember. Am I still doing the yield from, so I need to continue that? Or am I done? Like, you'd have to have like very complicated state. You basically be re-implementing kind of a mini interpreter. This way, you get to use the Python interpreter, sort of, implementing your own mini interpreter. So remember how I said list is a way of iterating? So I was not lying, but I was not being completely truthful. Every single sequence constructor is a way of iterator, right? So list is a sequence constructor. It constructs lists, which are a sequence. Double-ended queue, also a sequence constructor. You can make a double-ended queue with a length of 0, but still, when you call the constructor, it will consume your iterator. And that's occasionally very useful. Sometimes you want to kind of eat up the iterator without taking any extra space, maybe because you want the side effects, right? For example, in here, the side effects are printing, right? So it prints, but it takes 0 space. Again, kind of an esoteric use case, but it's important to hold this use case in mind because there's very similar use cases to that will be important, and it's important to remember that these two have like almost nothing to do with each other. Okay, so any sequence constructor is a way of explicitly iterating to the end of your iterator, or any iterable, because it will implicitly convert it to iterator, and as I said, every generator is an iterator. I think it's important to repeat that because people will often kind of use these things informally and say, this is a way to consume everything from a generator. No, this is a way to consume everything from an iterable. A generator is an iterator is an iterable. So, like I said, like you can convert an iterable to iterator, but what other ways can you take an iterable and convert it to iterator? So it turns out there's a lot of functions in Python. The signature is take iterable, or maybe take several iterables, and return an iterator. It does not promise you that it will return a generator, but usually you don't care about the implementation. It does promise you that it will return an iterator, and that's very useful. It will be on demand, right? So it doesn't take any extra space. And so why do I mention that like there's a lot of functions like that? So I'm going to go fairly quickly through the function because there's a gazillion of them. And if I went to like all of them, it would take most of the talk. I have a lot of other stuff to get through. So there's like, lots more details in the handouts later. But I'll kind of cover like some of my favorites. So there's enumerate, which give you indexes, which is a good alternative whenever you see someone doing from I of range len, enumerate, better. Map, really useful, right? And again, always returns an iterator. It doesn't do all the things in the beginning. It does things on demand. Lets you run arbitrary functions on your iterables, which might be an iterator. So for example, or you can use filter. It's kind of nuanced with filter, and especially with partial, because partial has the order. So greater or equal to 5 means 5 greater or equal to the thing, which means it will give you all the things that are less than 5. In this case, 1 and 3, it skips a 10. Zip takes a few iterable and gives you an iterator of the tuples. Again, very useful when you need to kind of combine. And remember, these two can be completely different generators, which means each of them might have a different flow, and Zip kind of coordinates them. Super useful in many use cases. And then, if you don't find exactly the right stuff you need, you have arbitrary generator expressions, right? So if you can think it, you can code it, right? Like if you can think of a way to combine several iterables into an iterator, you can do that this way and just do it inline, right? So that's very useful. Now, sometimes, like I covered like the language and the built-in. There's a useful module that's called itertools in the Sun library, having functions like, so it's a Sun library module, and basically has like, even more advanced iterator algebra. So it has chain, which will combine iterators one after the other. Extremely useful, especially if you want like a little prefix before you do the real stuff to kind of, warm up something. You can have iSlice, which is a really, really good way to deal with infinite iterators. As you saw earlier, I can do infinite iterators just by not ever raising a stop iteration. This way, you can kind of like limit the potential size. You have count, which is an infinite iterator, which just count from 0 to infinity. Very useful, especially if you zip it up with something. And if those are not enough, there is a library in PyPI where they took all the suggestions from itertools documentation of like what cool stuff you can do and just did it so that you don't have to like copy and paste from the documentation into your code. So basically like a lot of like really useful stuff like chunked, which will give you chunks. Very useful if you want to batch process something, especially if it comes in via stream infinite. You can distribute, which is the opposite, right? So again, if you kind of want to give something to like several threads or several kind of async flows or stuff like that, you can kind of distribute like that. There's pickable, which is very useful when you want to kind of look into the future. So I want to stop one before I get to 3, right? So like the 0, 1, but I want to get, not do the 2, right? Like as soon as 3 is close, I want to stop, right? Like again, there's some use cases where this is useful. Pickable is like super useful, and you don't have to think, right? You just pick and use, otherwise you use the iterator as is, right? So this is amazing, I love it. And then there's windowed, which I really like for like doing ranges, right? So if you have like timestamps and you want to know the differences between the timestamps, like, for example, like, for like something like mean time between failures or stuff like that, that's basically all the code you need for that kind of stuff. So here are a few gotchas, right? Like so far I was like, super enthusiastic about iterators, right? And I was like, here's like, all the things that are really useful, but they are like weirdly mutable. And I kind of mentioned that because you'd often see iterators kind of mentioned right next to like functional programming, right? Because you saw the code I wrote before, right? Like, I had map and filter and kind of like very abstract flows that don't really kind of like, mutate everything and everything kind of flows. So it looks very nice and functional. Remember that like at the end point, it's not functional. It's like the opposite of functional. It's like super stateful, right? And this is like the example of how stateful it is. Once you consume an iterator, it has been consumed. If you try to consume it again, you'll get 0. This is the source of many subtle bugs. If you see a subtle bug like that, that means you did that. How do you avoid this bug? There's 2 ways. One, make sure you pass in the sequence. This will require you to refactor your code from being iterator focused to like passing in the sequence. That might be a lot of refactoring. So, a lot of code, but pretty efficient. The other way fixes it at like the point of consumption. So you don't have to refactor, but in return you have to kind of freeze the iterator, which can be very heavyweight in memory and time-wise, right? At this point, you have to do all the computation to freeze it. There's like more sophisticated solutions if you use more itertools, but that's probably enough. But like I wanted to kind of just be mindful of the bug and mindful that there are ways to fix it, as long as you think very, very carefully. Cool. And then my favorite bug. This is like everybody's favorite bugs. If you have a dictionary and you have an iterator on it, and you try to use the iterator, after you have mutated the dictionary, it will do this. This will be the sign that you are in a sad place. The ways to solve it, I don't really have time to delve into all of them, but like potentially using like immutable data structures instead of dictionaries is a good way of solving that. It is important to like know the shape of the bug. This is kind of the abstract shape. Usually that's not like the pure form of like how it would look. Usually there'll be a for loop somewhere in the middle. Like I said, for is a much more popular way of doing iteration. So usually that will come in a for loop, where in like one of the sub branches you call a functions that modify the dictionary. That's like, like usually how this bug looks. But this is kind of like the bug condensed. So I want you to see that. And remember that like whenever you see that, it's basically this, except spread probably across like 5 files. So now you have to track it down. But at least now you have kind of a thread, a memory hint to kind of, know what to look for. And, oh my God, this is my favorite bug, because this happens at the worst time. What do I mean by it happens at the worst time? Let's say that you have kind of complicated code, and there's some issues. Okay, well, let me kind of reduce, like, some variables. I'll comment out some of the complicated flows, so I can concentrate on, like, what's really happening. So, you know what? Okay, I have this function, it yields hello, and then it does a print, and then it yields goodbye, and potentially it's like being used in a very complicated unit test. And like the hello just causes a lot of printouts, and like so I'm trying to figure out what's going on. So I'm like, okay, let's comment out the hello. I don't actually need it right now. That's fine. I comment out the hello, and I run the unit test. And there's still a lot of printouts, right? There's still kind of a lot of junk. And I'm like, you know what? I actually don't need anything from this function for like, debugging my specific bug. I can comment out the goodbye too, because I don't need it. Those of you who have experienced it know what's going to happen. After I comment out the last yield, this is no longer a generator. Now it's a function. Now when I call it, it does stuff. When you call a generator, it doesn't do anything, right? It returns an iterator that will do stuff when you iterate through it. You'll see that now I get a printout of going, and the return value is none. So if I try to iterate through it, it'll just fail. The last yield you comment out stops it from being a generator. That is something you will encounter often if you kind of do this kind of debugging by kind of commenting out flows that you don't care about to kind of focus on the flow that you do. There is a trick. This is a trick. You do if false, yield, right? Because like for Python, that's enough, right? It doesn't care if it's true. It just cares that there's a yield somewhere in the function. For you, that's also great. And luckily, because it yields a none, that will also trigger the type checker. So if you forget to undo it before you check in, you'll remember. So very neat trick. And when you run into that, that might be the difference between you being very sad and you not being very sad. So I like showing that. Cool. So let me kind of, I think I'm like very close to the end. So I want to go over like, what I talked and like where I want you to take it from here. So we covered iterators and generators. Iterators are a very useful interface in Python, right? Like you saw that like there's like a lot of stuff that focuses on this interface between different flows. It's a good way to express some sort of something that kind of, gives you one value after the next kind of in a reasonable way. Implementing them used to be annoying, but with generators, implementing them is very nice. So if you use generators, you can easily implement iterators, and you get a good way to use that interface. You have basically a whole algebra that focuses on just-in-time stuff, right? You take stuff that you wrote that is just-in-time, and you combine it, with stuff like zip and map and chunked and windowed, and still everything is just-in-time, right? As long as you just call these functions, nothing happens. And they only respond to like being iterated on top of, and say if you slice it, it will be like, kind of limited amount of time. Right, so like everything here is like very just in time, which is very useful, right? You get to write your abstract code, and the implementation is just in time. That can also be confusing, right? And that's based on functions that's kind of actually like more nuanced than that. They accept iterables and return iterators, right? And they're composable tools, right? You can use map of a zip, of an slice, of a count, of like, and like do all of these things, right? So basically all these tools are like super composable. And luckily, because it's like such a useful interface, there's a huge ecosystem, which means if you want to do something with iterators, your first instinct should probably be not reach for like, kind of a really complicated generator expression. Your first instinct should be to do some research. Someone has probably solved this before, right? If you're starting to like implement something like windowed or chunked, or like these things are like very twiddly to implement. You don't need, right? And those are just from more itertools. There's tons of ecosystem outside of that. Right, consume that ecosystem, right? You're probably already used to that. You probably already have a lot of stuff people install. After you use it, consume it. And, oh God, that's very confusing. And finally, if you don't find something that is exactly what you need, you might have stumbled upon one of the missing parts. So definitely contribute back. Let's see what question they have. Have you implemented a custom iterator that is already in production? I'm curious to know the use case and your thoughts of itertools. So itertools SCD lib is absolutely amazing. Have I implemented an iterator that is in production? Quite probably. Like I don't really think about it, but I'm pretty sure that like I wrote some code that works like that. Probably like like part of my data analysis involves like an iterator that does that. So yes, I can think of like a specific example, but it's because I do it so much that like it's just like I don't even think of it as kind of a separate activity. I also got a question of whether Anthropic is hiring. The answer is yes, we are hiring. Catch me later, and I'm happy to give you my email address. What's my favorite iterator? Wow. I would say I have like a special weakness for windowed. Right, like like it makes like implementing stuff like rolling average just like almost mindless. Right, and like implementing these things are like typically hard. I'm used to like kind of there's so much work to kind of implement these things. Now implementing a rolling average is basically just map of windows or like map sum of windows and like then like map division, and that's it. Right, like I can implement it in like 2 lines of code. So windowed is just like magical, and I love it so much. How would you approach delving into these tools to learn them deeply? Just do lead code and reach for those tools. I would not say even lead code, right? Like when you have to write code, think, is this a natural, like if you see yourself iterating on something and you see a lot of code inside the for loop, that's your signal to think maybe there's a good abstraction I can do. And one of the reasons I like these abstractions, they're extremely testable. Right? If you test every bit of it, then you barely have to test the combination. So if you see a lot of code on the for loop, that's your kind of sign to like say, should I look into like implementing it with iterators? Isn't using a lib just for chunks encourage the well, so more itertools is not just for chunks. It has a lot of use stuff like window chunk that I didn't even cover half of it because like there's tons. I basically reach for more itertools. It's like the alternative is basically like you'll end up implementing it yourself, probably worse and probably with more bugs. I do not think it's left bad. Chunked is actually like not that trivial to implement if you remember all the annoying edge cases, like what happens if you can, if the stuff you have is not, directly divisible by the chunk size and stuff like that. So I would say, yeah. Cool. I think that is all the question, and I'm also out of time. Am I? Okay. Cool. So thank you.
Thank you.